Right at the center of our circuit diagram is the TEA2025B integrated circuit. This is our primary audio amplifier. You'll easily spot it by that 16-pin dual inline package, basically 8 pins on the top row and 8 on the bottom. This little chip does all the heavy lifting for dual-channel audio, and we're going to trace exactly how it's wired into the board, step by step.
Section 1. The core, focusing on the power supply and grounding.
If we trace the primary power source, just look at that red line labeled 12V DC positive. That routes directly into the top right pin, which is pin 8. But, power always needs a return path, right? So that brings us to our really robust common ground network. You can see it mapped out by the thick black wiring running around the edges. Notice how the chip anchors to this ground. Pins 4 and 5 on the top tie straight up into that rail, and pins 4 and 5 on the bottom mirror that perfectly, dropping straight down.
Positioned squarely between these main power lines is a 100 microfarad 16-volt electrolytic capacitor. You can clearly see its positive terminal tapping into that red 12-volt line and the negative side bridging right over to the black ground. Now, this isn't just randomly placed. It acts as a filter. It's there to smooth out any voltage hiccups before the power ever actually hits our amplifier chip, keeping the audio nice and clean.
Moving right along to Section 2. The left speaker audio pathway.
Starting at the top left, at pin 1, we find the primary audio signal for the left channel. If you follow this orange pathway, the signal hits its first junction, travels left, and goes right into a large 470 microfarad capacitor. After passing through that component, it routes straight into the left speaker. Then the circuit neatly closes by grounding the speaker's bottom terminal right back up to the top rail.
But wait, let's look back at that very first junction off pin 1. The signal also drops straight down into a smaller 100 microfarad capacitor. It loops right back up and feeds directly into pin 2. This actually creates a dedicated support loop for the left channel output, which is absolutely crucial for stabilizing the amplifier's internal circuitry. Now, from pin 2, the path branches again. Trace the orange line moving upward into that green 154 nanofarad film capacitor. Once it's through there, it terminates straight into the ground rail. This setup acts as a high-frequency ground filter specifically for this side of the channel.
Moving further right along the top row, pin 3 connects to another 100 microfarad capacitor. But check out how it bridges over to connect back into pin 6. And right next to it, a green 224 nanofarad capacitor creates a second bridge linking pins 6 and 7 together. It's like a tightly woven little network up there.
Next up is Section 3, the right speaker audio pathway. So for the right speaker, we start down at bottom pin 1. Just like we saw on the top half, the orange line heads left into a 470 microfarad capacitor, exits directly into the right speaker, and grounds out at the bottom rail. It's the exact same journey, just mirrored perfectly.
Heading back to the junction immediately off that bottom left pin, the connection splits and travels upward. It enters the positive terminal of a vertical 100 microfarad capacitor. The signal then returns from the negative terminal, traveling downwards to connect directly into the second pin from the left on the bottom row. Again, this mirrors the exact same support loop we just traced on the top half.
At that bottom pin 2 junction, the signal drops right into a green 154 nanofarad capacitor, which then ties directly into the bottom ground rail. So this is handling the high-frequency filtering for the right side of the circuit.
Finishing up the bottom row here, pin 3 routes through a 100 microfarad capacitor, bridging its negative terminal right over to pin 6. And just as we saw above, a green 224 nanofarad capacitor completes the picture by bridging pins 6 and 7. That brings us to Section 4, Filter and Support Capacitors.
Let's take a quick audit of our 11 capacitors, because the layout is incredibly organized. We've got 2 large 470 microfarad electrolytics sitting right in line with the speakers. Then there are 5 smaller 100 microfarad electrolytics handling the IC pins and the main power filtering. Finally, our green film capacitors round everything out. 2 154 nanofarad caps routing pin 2 to ground, and 2 224 nanofarad caps bridging across pins 6 and 7.
What this breakdown really reveals is the absolute elegance of the circuit's perfect symmetry. The top half drives the left channel using pins 1, 2, 3, 6, and 7. Then the bottom half drives the right channel by mirroring that exact same pin usage and capacitor layout. It's a beautifully balanced design.
Finally,
We trace our very last visible connection, which is pin 8 down on the bottom row. The path exits this pin, enters the positive terminal of our final 100 microfarad capacitor, and terminates straight down into the common black ground rail.